Now in this lecture, I am going to tell you how to go about matrix addition using an algorithm. Right. So this is our first matrix. Matrix means 2D array. And as you can see, it happens to be of the size 3 by 3. There are 3 rows, 3 columns. And I intend to add the elements of this matrix A to the elements of matrix B. That means I want to go for matrix addition. And the result should be put into a resultant matrix, name of which would be C. Name could be anything, of course. So as you can see, matrix addition is a very straightforward process. For example, in case of 2D array A, the first row, first column element of A would be added with the first row, first column element of the matrix B, and that will be assigned to the element which is at first row, first column of the resultant matrix C. So on, it will go on like this. Similarly, the element at the first row, second column of the matrix A would be added to the element at the first row, second column of the matrix B. It will give us 22, and that will be stored as the first row, second element of the resultant matrix C. So it's a straightforward process. So let me take you to the algorithm. So this is the algorithm that I have built. So here what I am going to do is, as you people are already familiar with C and you have written a lot of programs related with 2D arrays, even if you haven't written many programs of 2D array in C, you might have written only simple programs of 2D arrays in C. So you must be knowing that when we people traverse the elements of a 2D array, we are supposed to apply nested loops. The outer loop is meant to traverse the rows of the matrix, and inner loop is meant to traverse the columns of the matrix. So I have to have two counter variables. So in this case, I am going to take I and j. The I counter variable will be used in the outer loop, which is meant to traverse the rows, and j counter variable will be used in the inner loop that will be used to traverse the columns of each row. Okay, at step number 3, I'm starting with my outer loop. So repeat steps 4, 7, 8 while I is less than equal to 3. I'm going to repeat the steps 4, 7, 8 and while I is less than equal to 3. And this is the outer loop meant for traversing rows, and condition is true for the very first time because value of I is only 1. And it will go to step number 4. And in this case, we are going to traverse the columns. So while j is less than equal to 3, condition is true. So that means we are supposed to repeat steps 5 and 6. So control will go to step number 5, where I have written set Cij colon is equal to Aij plus Bij. Now value of I and j both is 1. So it means A11 plus B11. So whatever is element is there at first row, first column of A matrix, that will be added with the element which is at first row, first column of the B matrix, that is 2D array. So the result will go into C11. So that means we have obtained the first element of the resultant matrix. Now we want to move to the element which is at the first row, second column of both the matrices. So what I will do is, I will increment the value of j by 1 because j is the counter variable for inner loop, and inner loop consists of only 2 steps 5 and 6. The control will go up to the inner loop, to the beginning of the inner loop. Condition is true because value of j is 2 now. Now see what will happen here. Value of I is still 1, and that of j has been upgraded to 2. So this is A12 plus B12. That is the element of the matrix A which is at first row, second column will be added with the element which is element of B which is at first row, second column. So both the elements, corresponding elements, will be added and the result will be put into C12, right? So similarly, now we want to move to the next column. So set j colon is equal to j plus 1. Now value of j will become 3. The control will go up. Condition is true because j is less than equal to 3 is the condition. So we are moving the columns. We are traversing the columns of our matrices, not rows. So because right now the value of I is only 1. So now it means A13 plus B13. That will be added and result will be put into C13. Again, value of j will be incremented by 1. That will become 4. it will go up and check the condition of the inner loop, but that will be false now because value of j has reached 4. The inner loop will be terminated. The control will go to step number 7 and 8. As you can see, step number 7 and 8, they are part of the outer loop. So value of j, that will be value of I will be incremented by 1 at step number 7 because we are going to change the row, right? So value of I will become 2 and j will be reinitialized to 1. Why j will be reinitialized to 1? Because we are going to move to the second row, and of course we will be traversing from the scratch. That means from the very first column of the second matrix. And this is how the whole process will go on. And you can go for a dry test yourself and you can see the logic. It's a very simple logic. And let me show you the same algorithm, but this time over using repeat for loop. As you can see, it is quite easy to write the algorithm of matrix multiplication, or for that matter any algorithm that involves in nested loops using repeat for than using repeat while. So repeat for I is equal to 3, repeat for j is equal to 1 to 3, and set c ij colon is equal to aij plus bij. It's very simple. So because you know that incrementation by 1 is automatically is something that automatically takes place. So this is end of inner loop, this is end of outer loop. So this is the algorithm that involves matrix addition.